So we're looking at page 5 on exam 3 from spring 2018. And this question is basically asking to apply what we know from the mechanisms in chapter 6 to a mechanism which we may have not explicitly seen yet. And if you remember, I told you that the whole purpose of understanding a mechanism is that we will start to see these same steps over and over in different reactions. And so what I'm asking you guys to take a look at here is say, hey, look, here's a reaction that we haven't explicitly talked about in class, but with the knowledge that you guys got from your studying from chapter 6, we can see these exact same mechanistic steps that we saw in chapter 6 applied to a reaction that will come later on in your organic career. Okay, so we're going to be starting to look for some of these, what I call flags, these common things for you to start to pay attention to as you're going through and assessing a mechanism. There's some information given at the top. It says that an epoxide is a three-membered ring with an oxygen, right? So basically this functional group right there, right? They can be reacted with mild acids under aqueous solvent conditions to ring open and form a transvicinal diol. Right, so there's a lot of very important things in that statement. So aqueous solvent, that means we got plenty of water around. That means we can use water to shuttle around protons and things like that. Acids, right? And I told you guys a lot about acids, right? There's a whole chapter about acids and bases in the book, but remember I said acids are one of those things that usually they are used in the first step of a reaction mechanism, right? Very commonly we see them used in the first step. And so if I'm telling you guys there's an acid around, make it act like an acid. And if there's an aqueous solvent around, that means we got some water in case we need to shuttle things around. It tells us that we ring open. That's a common thing we see with three-membered rings, that they kind of pop open, right? And that's kind of because of that ring strain. That's kind of a driving mechanism for that. And they form a trans, right? So one wedge, one dash, vicinal, that means they're next door neighbors, and a diol, right? So two alcohols. So a wedge dash neighboring two alcohols gets formed. So a bunch of information up there. Okay, so let's take a look at step 1, right? If you see what happens here, we have an acid, our strongest acid under aqueous conditions, H3O plus hydronium. And so if we have an acid, make it act like an acid. That means something's going to come in, grab a hydrogen, you make a bond, you break a bond. Okay. So simple first step that we've seen a billion times in chapter 6, right? An acid, the hydrogen of an acid getting attacked by something acting like a base. Okay. Now, next step here. Okay, so now we see this, right? Protonated three-membered ring intermediate with a positive charge. So where have we seen this before? Well, the answer is, right, if you take a look, either previously in these videos or in the book, right, anytime we go through what I call these Sumo mechanisms, right, these three-membered ring intermediate mechanisms, we see a three-membered ring with a positive charge on that ring there. So this is a similar setup to something we've seen before. So remember, that oxygen isn't really feeling plus. It's lifting up one of its legs, right? It's breaking one of its bonds, right? It's stretching one of those dashed bonds. And when it stretches one of those dashed bonds, it leaves behind a partial positive charge, a carbocation-like state. And so we have the choice, right? We have that orange, and let's use green here, okay? So the orange and the green. That oxygen's playing sumo wrestler there, right? It's lifting up one of its legs, and it's going to leave behind a plus on either the orange or the green. So which of those two carbons is better at handling that plus charge? So the answer is the same here as we would expect for a carbocation, even though a carbocation isn't really formed, right? Not in a carbocation that we might expect, at least. So the orange carbon is better at handling that positive charge. So that is where our incoming nucleophile is going to attack. So water is going to come in, right? Hit that carbon, you make a bond, you break a bond, okay? And remember that incoming water, this guy, is coming in from the opposite side of where the oxygen is in the three-membered ring. You'll notice the oxygen in the three-membered ring is dashed, So our incoming water is wedged, and that's why you see that right there, right? And that's where our transvicinal diol starts to come into play, right? Now we have to complete the reaction, okay? So I kind of left you guys high and dry here, so to speak. Say, oh my gosh, what do we do next, right? So let's sketch in what we have. All right, we're taking our stuff from part 2. And we say, okay, what's the problem that we have to solve? Well, the problem we have to solve is that we got an oxygen with a plus charge, a protonated alcohol. A very common thing to see, but we need to help that oxygen out. So to help that oxygen out, we need to get rid of one of its protons, right? We need to take one of its bonds and turn it into a lone pair. And here is where the other part of the information is used, right? We said we were under aqueous conditions, so we can bring in some water. So we bring in some water, we make a bond, we break a bond. Whoops, sorry, I don't know why that turned into a square, right? Okay. If we follow those mechanistic arrows, right, we've got our six-membered ring here. There's my deprotonated alcohol now. There's my OH that came from the ring, the three-membered ring to begin with. And let's just make some colors here. Right, and there's a hydrogen that got picked up from that protonated alcohol. So very similar to what we expect to see from the mechanism such as the halohydrin mechanism, right? Oh my gosh, I'm sorry guys. The halohydrin mechanism or our halogenation mechanism even shares some steps with this. So pay attention to what information is given. Think about what it means to be an acid. Think about what it means to be a solvent, and what trans means, what vicinal means, what diol means, right? These kind of clues that were given along the way.